Bad news for the planets of Barnard Starr. Measuring the atmosphere on a rocky world within the habitable zone. Identifying the asteroid that killed the dinosaurs, and how the Milky Way flipped its disk. And on Space Bites Plus, how global Martian dust storms can get even worse. All this and more in this week's Space Bites. One of the closest star systems to the solar system is Barnard Starr. This is like, you've got the Alpha Centauri, Proxima Centauri system, and then after that you've got Barnard Starr, and it's less than 6 light years away from us. And one of the really exciting things recently discovered is that there are 4 planets orbiting this red dwarf star. Well, we've got a new story from Matt Williams that suggests that perhaps they are not the most habitable exoplanets. So astronomers analyzed the chemical fingerprint of Barnard Starr itself. And from that, they determined that any planets that are in the system have to be high in this chemical called periclase. It's a type of magnesium oxide. The problem with periclase is that it does not hold on to water. On Earth, we have a different version of magnesium oxide called olivine, and it holds on to water. That can explain why there's so much liquid water on Earth and within the solar system. And so that is sort of like a chemical reason why these planets are probably not very habitable. But then the other problem is that they are very close to the star, and that the constant radiation from Barnard Starr would have scoured away all of their atmospheres billions of years ago. And you've got to understand, this is a red dwarf system. And so although it is putting out less radiation, its habitable zone is very small. And the planets that are orbiting around this star are within like 1 and 4% of the distance from the Earth to the sun. So they are incredibly close. And as we've talked about this in the past, red dwarf stars are putting out so much radiation that it can scour the atmospheres off of any kind of planets that are around them. The planets are almost certainly tidally locked, but also go through various tidal interactions with each other. But it's possible that the planets held on to their atmospheres probably within about the first 2 billion years. And then as this radiation pressure from the star was building up, they finally lost all of their atmospheres. This is the kind of story we're going to hear time and time again as astronomers attempt to analyze the atmospheres of red dwarf stars. Except when astronomers analyzed the atmosphere of a planet around a red dwarf star, they were able to detect an atmosphere. And this is the second story that we're going to do on this theme, and this time it comes from Mark Thompson. This is a star system that we've talked about quite a bit called LHS 1140. And there are a couple of exoplanets in orbit around it. It's located about 48 light years away from the solar system. Astronomers know that the closest planet in the system, LHS 1140b, is a type of super-Earth, so it is much larger than the Earth. But it is within the habitable zone of the star. And it has another planet that is in the system as well. And so astronomers are watching a planetary transit as the 2 planets were passing in front of the star. And this gave them the perfect way to compare the composition of their atmospheres. They used a telescope in Chile called the Magellan Telescope. And don't confuse this with the upcoming giant Magellan Telescope. This is a 6.5 meter version, not the upcoming 30+ meter version of the giant Magellan Telescope. And according to their calculations, 1140b should have an atmosphere that contains a lot of helium, and that because this planet is very close to its star, it will be leaking this helium atmosphere out into space. And so they were watching this transit, watching as the 2 planets passed in front of the star. And so with 1140b, they were able to detect the presence of helium in the vicinity of the planet. And then when the other planet, 1140c, went by, they didn't detect the presence of that helium. And so they were able to determine not only that there is a helium atmosphere at this planet, but it is also escaping into space, which goes back to the previous story about how planets that are orbiting around red dwarf stars, especially when they're very close, are going to lose their atmospheres to space over time. It was over 100 years ago that Einstein came up with the theory of general relativity. Up until this point, astronomers made their predictions about the movements of the planets in the solar system based on the calculations from Isaac Newton. But there were like a couple of edge cases, especially the movement of planet Mercury, which caused astronomers to know that there was something wrong with their calculations. They thought, well, maybe there's another planet, the planet Vulcan, that is influencing Mercury with its gravity. When Einstein came up with the theory of general relativity, he was able to explain this difference in the movements of Mercury. And so most of the time, Newtonian dynamics is good enough, but there are these edge cases, places where you've got physics in the extreme that astronomers are able to test out the predictions made by Albert Einstein. So there is this place in the Milky Way where you've got things moving in the extreme, and that is the stars that are orbiting around the supermassive black hole at the heart of the Milky Way. You've got these stars that are moving in comet-like orbits around this black hole. Some get so close that you really need general relativity to explain their motions. And so a new paper came out that talked about this star called S301. And this is the 301st star that has been detected in the environment around the supermassive black hole. It makes one of the closest approaches to the supermassive black hole. It comes within the distance of around Uranus and Neptune if the solar system contained the supermassive black hole at the heart of it. And when the star reaches its closest approach, it's going 8% the speed of light. And so now you've got this relativistic speed, and this allows astronomers to measure second order relativistic effects on the star, including how its orbit changes, precesses over time, similar to the way that Mercury's orbit precessed around the sun. And it's thought that with better telescopes, like the giant Magellan telescope that I mentioned previously, but the actual one that's under construction right now, or say the extremely large telescope, astronomers will be able to measure the movements of these stars with such precision that they will be able to detect third order effects predicted by general relativity. The Milky Way looks like it's a giant spiral galaxy, but there's actually two separate disks that we are embedded within. The first one is called the thin disk, and this is what really looks like the spiral arms of a galaxy like the Milky Way. But then there's this second disk that surrounds the thin disk called the thick disk. And this thick disk, this halo of stars that surrounds the Milky Way, was thought to have been formed through various mergers that happened with the Milky Way and other galaxies. Well, now I've got a story from Evan Gogh about how analyzing the thick disk tells us that it looks like the Milky Way did a disk flip in the past. So, of course, the discovery came from analyzing the movements of stars thanks to the Gaia mission. Astronomers know that billions of years ago, there was a colossal merger with the Milky Way. This is called the Gaia Enceladus sausage. It's sort of like named after a blob of stars that are moving through the galaxy that were part of this merger. And that when they measure the movement of those stars and measure the movements of the stars in the thick disk, it shows that the stars have moved on very different trajectories than they do today. That at some point in the past, the Milky Way's disk had flipped over. And that this is probably connected to the larger dark matter halo that surrounds the Milky Way. Recently, astronomers figured out that this was actually a little more twisted and not as spherical as astronomers had originally believed. At some point in the past, the Milky Way flipped over. About 66 million years ago, a giant asteroid smashed into what is now the Yucatan Peninsula in Mexico. The resulting fireball, the raining rock that came down around the world, the fires, and just the general devastation went on to kill about 3/4 of all of the plant and animal species on Earth. And it was the death blow to the dinosaurs. This is the Chicxulub meteor event. And this impact created a 180-kilometer crater, or 112 miles, and it created this giant complex of limestone caves under the region that are filled with water. And now astronomers have been able to analyze the layers in the vicinity around the crater to figure out exactly what kind of asteroid smashed in and killed the dinosaurs. So they compared the nickel isotopes in the clay layer with other meteorite samples found on Earth. They found that a carbonaceous chondrite is the most likely culprit. Now, these are not very common asteroids. They're only about 5% of the meteorite samples that astronomers have found so far. And that asteroids like this probably came from the outer asteroid belt, or maybe even as far as the Kuiper belt. Every week we do a vote on our channel where you tell us what you thought was the best space news story of the week. And the winner last week was the dragonfly gets its shape. So thank you everybody who voted last week. Of course, we're going to put this week's stories into the post tab here on our YouTube channel. So go there, vote. And of course, if you want the best chance, subscribe, click on the notifications bell, like this video. obey the algorithm. Whenever an asteroid comes close to the Earth, astronomers scramble to get their hands on giant radio telescopes to be able to analyze the asteroid. And it's not just a radio telescope. You actually want a radio telescope that is equipped with a radar. And so astronomers will fire out a pulse of radio waves. It'll bounce off of the asteroid and be collected again. And this allows them to actually map out the surface of the asteroid in incredible detail. And we've got a story from Andy Thomaswick about how astronomers tried to do this, but the asteroid had moved because it's not an asteroid at all. So the asteroid is called 1998 SH2. And so in 2025, this 380 meter asteroid was going to fly within 0.02 astronomical units of the Earth. So that's very close, close enough to use this radar blast to measure the surface of the asteroid. Astronomers were using the 70 meter Goldstone antenna, which is also used to communicate with spacecraft across the solar system. And they looked at their data and the asteroid wasn't there. And it should have been there. It's a pretty big rock. They knew where they were pointing this thing, and yet there was nothing in their data. But other astronomers were watching this flyby event, and they were able to see the asteroid was moving through their field of view. It just wasn't exactly where the Goldstone antenna had been pointed. It turns out it was 190 kilometers off target. And this is not the kind of behavior that you get from an asteroid. There are minor changes that asteroids can make. There's this process where sunlight will heat up the asteroid. It will give off heat, cause it to rotate and get these tiny thrusts in different directions. But that was not enough to move it this far away. The only thing that can move that much is a comet. Comets have outgassing, which acts like a thruster, pushing the comet around. And so this asteroid was behaving like a comet. And so astronomers did follow-on observations with a giant telescope on Earth, and they were able to detect this faint coma around the asteroid, which I guess we should now call a comet, because it had actually been outgassing as it was making this close approach to the Earth, closer to the sun, and that was causing it to drift off course from where it was originally expected. So don't assume that every asteroid is actually an asteroid. Some of them might be dark comets. Now I'm going to show you a beautiful image captured by the Dark Energy camera. And this picture is really reminiscent of like Starry Night, painted by Vincent van Gogh. And actually the writer who got this story was Evan Gogh. And so, no relation? Maybe I should ask him. So this is the Corona Australis molecular cloud, and this is a star-forming region that is here in the Milky Way. And this nebula has everything going on inside of it. So you'll see a bunch of colors in this image. And this is an emission nebula. So you've got the radiation coming from the nearby stars that's heating up the gas that is surrounding them, and it's now giving off this reddish light. But then you've got these blue parts in the nebula, and these are reflection nebula. So you've got bright blue light coming off of these young hot stars that is reflecting off of this nebula, and we're able to see it. And then you've even got some dark nebula regions, places where the gas and dust is blocking our view to whatever is behind it. So really this nebula is the whole package. And then in the upper right, you've got a globular cluster, which is much farther away than the foreground nebula. It's called NGC 6723. It's the chandelier cluster. So that's it, a beautiful picture taken by the Dark Energy camera. NASA's Psyche mission is on its way to the asteroid Psyche, but it won't get there until August 2029. And on its way, it was able to make a flyby of Mars. And the main purpose was to get a gravitational assist, to change its trajectory to make it easier for it to actually go into orbit around asteroid Psyche. But it was also a chance to test out all of its instruments and cameras as it was making this flyby of Mars. And so NASA has released a time-lapse video showing you the close approach of Psyche to Mars from Psyche's perspective. And this was also a chance to test out some of its instrumentation. One of these is the magnetometer on board the Psyche mission. And this is what it's going to be using to help really understand, is asteroid Psyche a metal asteroid? Is it the chunk of an old planetoid, or is it something else? Is it more rocky? So Psyche came within 3,500 kilometers of the surface of Mars, or 2,200 miles, and was able to test its magnetometer, other instruments, and then take some really great close-up pictures. You're looking at the Huygens crater, which is the 5th largest impact on Mars. Now Psyche is on its way to asteroid Psyche and will be there in August 2029. And that story was written by Evan Gogh. I hope you're enjoying this week's Space Bites. As you can see by my complexion, I've been out in the sun quite a bit, and that is because I am on the summer hiatus where I'm not doing the weekly live streams. We're back in a little over a month, but we've still got tons and tons of content coming out from Universe Today across all of our channels. And one of the big things that we just dropped was our monthly question show from the patrons. This is over 3 hours long and contains dozens of questions asked by the patrons, answered by me and my producer Anton, who's also the editor on this very video. It's kind of reminiscent to the live question shows. Definitely come to Patreon, and then you'll get access to not only the episode we just dropped, but the entire backlog, which now we have 100 hours of patron-only questions. And of course, if you do watch this episode over on Patreon, you will get a longer version with one additional story. I'll put a link in the show notes. Now, this is just a fraction of the space stories that we are covering on Universe Today. Now, if you want to see on top of everything, you can just reload the Universe Today webpage every few minutes. Or you can subscribe to the RSS feed. People use RSS readers still, right? I do. But if you want it all in one place, you should definitely subscribe to my weekly email newsletter. I write every word in the newsletter. It's completely free. There's no ads. It goes out every Friday and contains a summary of every single story that we're covering on Universe Today. Read that and you will be completely up to speed on what's happening in space. Go to universetoday.com/newsletter to sign up. It looks like YouTube is still unsubscribing people from this channel. We're going to talk about that in a second, but first, I'd like to thank our patrons. Thanks to Abe Kingston, Andrea Progetti, Brian Bodie, Caradwin, Chuck Hawkins, Commander Baylock, Dark Finger, David Gilton, and David Matz, Enthrall Reading and Math for Toddlers, Evan.pro, James Clark, Jeremy Madden, Jim Burke, Marcel Smith, Michael Purcell, NASA Ocean Guy, Nordspace, OneStepForAnimals.org. Please follow my nephew at vbrick6994, Rain Kaidu, Richard Williams, Sean Sargent, Stephen Foundland Team 49, Telescopes Canada, Vlad Zeppelin, Wolfgang Klutz, Zelda, It Was Funnier in My Head, who support us at the Master of the Universe level, and all our patrons. All your support means the universe to us. So I get this message all the time on the YouTube channel, and that is that people are getting unsubscribed by YouTube. And this has been a problem that has plagued YouTube for a very long time, and I'm sure some of you have experienced this. Here's a message that I got from Mojojo724. Wow, I just realized I haven't seen your videos for a few weeks now. Somehow I got unsubscribed. Great to see you again. So sometimes you just get unsubscribed. Other times, the algorithm just decides that you no longer want to watch space videos from me. And that may be your intention. Yes, you're kind of done, you're over, you've moved on to new topics, but maybe you are still interested in space and you are kind of surprised that my videos are not showing up. And I have no control over this. You have no control over this unless you subscribe, click on the notifications bell, and go back and check the channel manually or something, because YouTube just doesn't give you a really easy way that you can count on to get these videos every time. So a thing that I'm always talking about is that you can follow us on Patreon for free. I got to be really clear about this, because I'm sure when I say the word Patreon, you think, okay, Fraser wants my money. No. You can go to Patreon and you can follow us for free on Patreon. It doesn't cost you any money. And then you will be getting new reminders, notifications of every time we post a video into the Patreon app if you use that, or you'll get an email notification when we've released a new video, and we release our videos at the same time. Of course, these are the ones that are longer. And that this is a way that you can maintain a constant connection with me and the work that we're doing. And it's perfectly fine. If you don't like the content that much and you're fine to just let the algorithm decide for you, well, then just keep doing that. But if you do enjoy the content and you want to make sure that you get it on a regular basis, then go to Patreon and subscribe. You can still watch it on YouTube if you want. I know they don't have a TV app, but it's a great way to know every time we've released a new video. All right, we'll see you next time.